Hello, children. Welcome to Deeksha Online Classes. Today, Matrices and Determinants. We start from lecture 12. In the last classes, we had inverse of a matrix, definition, its properties, etc. Today's class, we continue with the linear equations, a system of equations. And how do you find the solution for the system and consistency of the system? Let's see that. So what is meant by a system of solving a system of linear equations, and we will see that one. First we will see that what is the definition of the system of equations. In the system of equations, we have in our syllabus two equations, two unknowns system, three equations, three unknowns system. So what is two equations, two unknowns? A system written in the form like a1x plus b1y is equals to c1, a2x plus b2y is equals to c2. Two equations and two unknowns x comma y represents two equations in two unknowns x comma y. In the matrix form, this can be written as like this. Ax is equals to b, where A is nothing but actually the matrix A1, B1, A2, B2. And X matrix is equals to X, Y, and the constant matrix is called C1, C2. I say this A is called coefficient matrix. It's called coefficient matrix. And this is unknown matrix, constant matrix. So it is a constant matrix. This is said to be a system of two equations and the two unknowns. In the same way, three equations in three unknowns is of the form a1x plus b1y plus c1z equals to d1, etc. And this system also can be put up in the matrix form like ax is equals to b, where a is nothing but actually the coefficient matrix with the coefficients a1, b1, c1, a1, b1, c1. Similarly, a2, b2, c2, a3, b3, c3, and the constant, unknown matrix, that's nothing but actually x, y, z, and B matrix is equals to D1, D2, D3. This is actually a system of equations, three equations in three unknowns, written in the form Ax is equals to B, where A is called coefficient matrix, X is unknown matrix, B is a constant matrix. Now my concentration is to get the solution of this one. But before finding the solution of this system, there is a need in checking whether the system has a solution or not. So that is called consistency of the system. That's called consistency of the system. Yes, of course, what I wrote here, Ax is equals to B is written as like this, and the system equations. So equations can be written as Ax is equals to B, where A is a coefficient matrix, unknown matrix, and the constant matrix. Let's see the consistency. Consistent system of linear equations. That's called consistency. Means nothing but a system is said to be consistent if it has a solution. A system is said to be consistent if it has a solution. If it has a solution. If it has a solution, the system is consistent. If it has no solution, system is said to be inconsistent. A system is said to be inconsistent if it does not have a solution. No solution exists. If its solution doesn't exist. Okay. Now, in the first cases, we will check whether the system is consistent or not. Means we check whether the system has a solution or not. So what is the test for consistency? Let us see that the test for consistency of the system of equations is like this one. If the determinant of the coefficient matrix is not 0, then the system has a solution, and the solution is A inverse B, and it is consistent, it has a unique solution. If the determinant of A not equals to 0, that means if it is singular, then we have to calculate adjoint A into B also. Then we check if adjoint A multiplied by B is not equal to 0 along with the det A equals to 0, then the system is inconsistent, then it has no solution. If the adjoint A into B is equal to 0, then the system is consistent and it will have infinitely many solutions. So I will put up like this one in the simplest way. Det A not equal to 0, unique solution. Det A not equal to 0, unique solution. If det A equals to 0, additionally you need to calculate adjoint A into B, check whether it is 0 or not. If both of them are 0, it has infinitely many solutions. And if only one 0, the other one is not 0, then there is no solution for the system. Hope you understood here. So let us proceed. The examples based on this particular concepts. Ax is equals to b. But before that, I would like to go for one thing. If det A not equals to 0, we have the system has a unique solution. That means A is a singular, non-singular matrix. And finding the solution for the system, if it is a det A not equal to 0, that is called matrix inversion method, and that method we will see that one now. Matrix inversion method. In this one, if you are given a system Ax is equals to B, suppose Ax is equals to B is a system where A is not is equals to, determinant of A not equals 0 means A is a non-singular. Once A is non-singular, A inverse exists. It means A is invertible. If A is invertible, I could multiply both sides A inverse like this. If A is non-singular, its inverse exists. For this one, I pre-multiply A inverse. I get X is equals to A inverse B, because A inverse into A is identity matrix multiplied by X is same X as it is. And that is nothing but A inverse B. And that can be written as inverse of the matrix. We know that is nothing but adjoint A divided by det A multiplied by B matrix. So X is nothing but actually adjoint A by det A into B. Of course, as I told you, that one A is non-singular means a determinant of A not equal to 0. It is defined. Okay, this is the method of this is called matrix inversion method. So when the system is consistent and the A is non-singular, then we find the solution for the system in matrix inversion method like this. Now we shall proceed example on this one by one. Examine the consistency of the system. Examine the consistency of the system. How do you check? We check the consistency by taking first determinant. It is enough if we can check the consistency. And this system can be written in the form 2x plus 2y is equals to 2. And 2x plus 3y is equals to 2x plus 3y is equals to 0. Here this can be written as 1, 2, 2, 3, then multiply by column matrix xy, and that is equals to 2, 0. This is nothing but in the form ax is equals to b, which is a system of two equations in two unknowns, where A matrix is equals to 1, 2, 2, 3, whose determinant of A is equals to 3 minus 4, which is equals to minus 1, which is not 0. So as a determinant of A not equals to 0, that implies system is consistent. System is consistent. It has unique solution. So the answer is system is consistent and it has a unique solution. Let us proceed to second example. Examine the consistency of the system of equations. 3x minus y minus 2z equals to 3x minus 2y minus 2z. So 3x minus 2y minus 2z. 3x minus y minus 2z is equals to 2. 2y minus z is equals to minus 1. And 3x minus 5y is equals to 3. If we can rewrite in the matrix form as like this, that can be written as it is 3 minus 1 minus 2, 0, 2 minus 1. So 3 minus 5, 0. Multiply by xyz, and that is equals to 2 minus 1, 3. This is in the form ax is equals to b. And you have, this is the matrix A. Let me take up determinant of A is equals to determinant 3 minus 1 minus 2, 0, 2 minus 1, 3 minus 5, 0. That is equals to, it's a 3 multiplied by 0 minus 5 minus 1 multiplied by 0 plus 3 minus 2 multiplied by 0 minus 6. And that is equals to minus 15 minus 3 minus of minus 3. So let me take up. So 3, it is 2, 0 minus 5 minus of minus, I hope it's plus 3. Yes. Plus 12. And that is equals to 0. Determinant of A is equal to 0. System has no unique solution. It has not having any unique, the system has no unique solution because det A is equals to 0. Now along with this one, I need to check the adjoint of the matrix, and then we have to find adjoint A multiplied by B. So to calculate, I consider the A matrix is equals to, it's a 3 minus 1 minus 2, 3, 1, 3 minus 1 minus 2, 0, 2 minus 1, 0, 2 minus 1, 3 minus 5, 0, 3 minus 5, 0. This is A matrix. Let me consider the cofactors of elements of A. And that is given by, it is the determinant of the first row, first column element. You'll be getting 2 minus 1 minus 5, 0. And second element, 0 minus 1 3, 0. For this, you have to take minus sign for the cofactor. And the third one, 0, 2. Yes, 0, 2 and 3 minus 5. And the next one, cofactor of 0, minus 1, minus 2, minus 5, 0 with minus sign, minus 1, minus 2, minus 5, 0. Cofactor of 2, it's a 3 minus 2, 3, 0. And cofactor of minus 1, 3 minus 1 and 3 minus 5 with minus sign. And cofactor of 3, minus 1, minus 2, 2 minus 1. And the cofactor of minus 5 will be 3 minus 2, 0 minus 1 with minus sign. And 3 minus 1, 0, 2. And that on simplifying these values, it gives us here 0 plus minus 5. You get minus 5 here. 0 plus 3 with minus sign. 0 minus 6. And the next one, 0 minus 10 minus plus 10, you get it. 0 plus 6. Minus 15 plus 1 plus 3. Minus 15 plus 3. 12. You'll be getting plus 12. Yeah, 1 plus 4, 5. And minus 3, minus of minus plus 3. And it is 6. This is about the cofactors matrix. And of course, the transpose of this one is nothing but adjoint matrix. Adjoint A is nothing but cofactor matrix transpose. So the transpose of this one. Now, we need to find what exactly the consistency of this one. So to calculate, evaluate adjoint A multiplied by B matrix. Adjoint is nothing but the transpose of this matrix. Minus 5, 10 and 5 row wise, and minus 3, 6, 3, minus 6, 12 and 6 multiplied by B matrix. The B matrix is equal to 2 minus 1, 3. That's a 2 minus 1, 3. Let me take up 2 minus 1, 3. And when you multiply these values, you get it. I hope you'll be getting minus 10 plus 10 plus 15. Obviously, this is not equal to 0. Definitely, this is not the null matrix. First number itself is not 0. Definitely, it is not a null matrix. Though it is minus sign, of course, it's not equal to 0. One number itself is not 0. Therefore, total determinant adjoint A multiplied by B is not 0. So, therefore, det A is equal to 0. At the same time, adjoint A multiplied by B is not equal to 0. It implies system is inconsistent. Inconsistent. And it has no solution. The system has no solution. Observe very carefully. Determinant of A is equal to 0, we got it. And adjoint A multiplied by B not equal to 0, system is inconsistent and has no solution. Right? That is the consistency, inconsistency of the system. Now we shall proceed to example 3. That is nothing but solving the system using matrix method. 3 minus 2, 3, 8, 3x, 3 minus 2, 3, 8. I shall write down directly the matrix form. This can be written as 3 minus 2, 3, 2, 1 minus 1, 4 minus 3, 2, and then multiply by x, y, z, and that is equals to 8, 1 and 4. And that is nothing but actually Ax is equals to B form, where A is equals to what? The given system can be written in the matrix form like this, where Ax is equals to B. A matrix is a coefficient matrix. So let me rewrite the A matrix. 3 minus 2, 3. A matrix. Okay, 3 minus 2, 3. 2, 1 minus 1, 4 minus 3, 2. In the inverse matrix method, inversion method, or by matrix method, when you are calculating it, we need to check first the determinant of the matrix. Let us check up this one. So the determinant of the matrix here, det A is equals to, it is the determinant of 3 minus 2, 3 and 2, 1 minus 1 and 4 minus 3, 2. 4 minus 3, 2. And the value of this is equals to, it's 3 multiplied by 2 minus 3 minus of minus 2 multiplied by 4 plus 4 and plus 3 multiplied by minus 6 minus 4 minus 3, 8 2s are 16 and plus 30 plus 30. So when you calculate, it is minus 30, I hope so, because minus sign. Yes, of course, 33 and 16, 13. When you simplify, this is equals to 30 minus 3, 33 and 16. So I hope we'll be getting 17, 13, right? Minus 17. And that is not equals 0. It means determinant A not equals 0 means A is invertible, A inverse exists. A inverse exists means then definitely the solution for the system Ax is equals to B, pre-multiplying A inverse X is equals to A inverse B, you get it. A inverse is adjoint A by det A. So I need to calculate what is adjoint A next process. To calculate, consider the cofactors of the elements. A. Cofactors of elements of A are given by cofactors. So first one, I hope the first one is 1 minus 1 minus 3, 2. 3 cofactor. Minus 2 cofactor, 2 minus 1, 4, 2 with minus sign. And 3 cofactor 2, 1, 4 minus 3, 4 minus 3. And the second one, cofactor of 2 is nothing but minus 2, 3, minus 3, 2 with the minus sign. And the next one, 3, 3, 4, 2. Next one with the minus sign, 3 minus 2, 4 minus 3. And the next 4 cofactor minus 2, 3, 1 minus 1. Next minus of 2, 3, 3, 2 minus 1. And the next one 3 minus 2, 2, 1. And these values after calculation gives us the answer as like this. So 2 minus 3. So 2 minus 3 minus 1. 4 plus 4, 8 minus 8. Minus 6 minus 4 minus 10. Minus 6 minus 4 minus 10. Minus 4 plus 9. Minus 4 plus 9, I hope it's 5 with a minus sign. Yes, 6 minus 12 minus 6. And minus 9 plus 8. Minus 1 minus of minus plus 1. Sorry, it's a plus 1. Next, I think 2 minus 3. 2 minus 3 minus 1. Minus 3 minus 6. Minus 9 minus of minus plus 9. And 3 plus 4 7. This is about a matrix cofactors of elements of the matrix A. Now the adjoint A is nothing but the transpose of this matrix, and we need to find what is called A inverse. A inverse is adjoint A by det A. So we know that adjoint of A matrix is nothing but cofactors matrix. So cofactor matrix transpose of it. And now we consider the system Ax is equals to B. I pre-multiply A inverse both sides into Ax is equals to A inverse B. And therefore we'll be getting A inverse into A multiplied by X is equals to A inverse B. And this is identity matrix into X. So X is equals to adjoint A by det A multiplied by B. Is what you get it because of A inverse of this. So I need to find X is equals to 1 by det A multiplied by adjoint A multiplied by B matrix. Therefore, X is equals to the product 1 by det A. We had the det A is equals to 1 by 17 minus 17 times adjoint matrix. Adjoint matrix is the transpose of this matrix. So I row wise if I take up minus 1 minus 8 minus 10 minus 1 minus 8 minus 10 column wise we write, and minus 5 minus 6 1 minus 5 minus 6 1 minus 1 9 7 minus 1 9 7. Yes, of course. This is about adjoint of A and the B matrix. B matrix is equal to 8 1 4 here. 8 1 and 4. 8 1 and 4. And that is equals to minus 1 by 17 times. Minus 1 by 17 times the product. So you'll be getting minus 8 minus 5 minus 4. First row, first column. Second row, first column. Minus 64. Minus 6. 36. Plus 36. Next minus 80. Plus 1. Plus 28. That equals to minus 1 by 17 times, and this is minus 17, 36, 64 minus 6 is 70 when you subtract, so you'll be getting 34, yes, with minus sign, 28, 29 you get minus sign, 80, so therefore here it is 80 minus 29. Subtracting it, I think it is 51. And the calculations, it is 17 divided by 17. First number, I hope 17 by 17, it's 1 and 2 and 3. You got the values as 1, 2, 3. So X matrix is equal to this one. So we have, I'll write here. X matrix is nothing but X, Y, Z, and that is equals to 1, 2, 3. And therefore, X is equals to 1, Y is equals to 2, and Z is equals to 3. This is about the solution for the system. Hope you understood. So, first inversion method, determinant of A you calculate. If the determinant of A not equal to 0, then inverse exists. And you find the cofactors of elements of the matrix. Cofactors matrix you calculate and take the transpose of it is nothing but adjoint of A. And Ax is equals to B, take up inverse multiply by both sides. You'll be getting X is equals to adjoint A by det A into B. And therefore 1 by det A into adjoint A into B. Calculate adjoint A into B, you get the matrix side values actually. That's about the solution for this problem. Let me proceed to the next one. Solve the system using matrix method. Of course, solve the system as we have the syllabus matrices only. We go for the matrix inversion method only. We stick on to this method only. I would rewrite this system in the matrix form as like this one. Matrix form, the coefficients are 2, 3, 10, 2, 3, 10, and second equation coefficients are 4, minus 6, 5, 4, minus 6, 5, and third one 6, 9, minus 20. Multiply by 1 by x, 1 by y, 1 by z, and that is equals to, it's a 4, 1 and 2, and this is in the form Ax is equals to B form. So where A matrix is this one, and this is X matrix, and this is a B matrix. Okay, let's take up A matrix and find the determinant first, and we check whether the determinant is equal to 0 or not equal to 0. Let's find out the determinant 2, 3, 10. Det A is equals to determinant of 2, 3, 10, 4 minus 6 to 5. So 4 minus 6 to 5, and 6, 9 minus 20. 6, 9 minus 20. Expanding this one. So 2 multiplied by 120 minus 45. Of course, bit carefully we need to write. Minus 3 multiplied by minus 120 minus 30 minus 120 minus minus 80. 4 2s are 80, 4 20s are 80 minus 30, and plus 10 multiplied by 36 plus 36, and that is equals to 120 minus 45. Hope it is 75. 2 multiplied by 75. Yes, of course. Plus 3 multiplied by 110 plus 10 multiplied by 72. Yes, of course. This is 150 plus 330 plus 720. 20 plus 30 is 50 plus 50, 100. And 7 plus 3, 10 plus, I think it is 200, 1200. So this value is equal to 1200. It is not equal to 0. So determinant of A not equal to 0 implies A inverse exists. So the matrix is invertible, and we can find the inverse of the matrix, and we can find the solution for the system. That means system has a unique solution. System is consistent, has a unique solution. So we find the cofactors of elements of A. Cofactors of elements of A matrix are given by. So let me calculate the cofactors of elements of the matrix. So first cofactor of 2 minus 6 5, 9 minus 20. Okay, and the second one, so 4 5, 6 minus 20 with a minus sign, and third one 4 minus 6 and 6 9, 4 minus 6 6 9, and second one 4 cofactor 3 10 9 minus 20, and for minus 6 the cofactor for minus 6 is 220. Of course this is minus sign. Here it is 2 10 4 5, 6 minus 20, and the cofactor of 5 2 3 6 9 with the minus sign. And next one cofactor of 6, it's a 3 10 6, 3 10 9 minus 20, 3 10 minus 6 5. Second one cofactor of this is 2 10 4 5 minus sign, and minus 20 cofactor 2, 3, 4, minus 6. And on simplifying these values, you'll be getting it as first one, I hope 120, the first number is 120 minus 90, 45. I hope it is 75. Next, minus 80 minus 30, 110. 36 plus 36, 72. 160 and 90. 150 minus 60 minus 90. 150. So minus plus sign. Minus 40 minus 60 minus 100. 18 and minus 18, of course it is a 0. So 15 plus 60, 75 with the positive sign. And 10 minus 40, I hope you'll be getting 30 with the minus sign. Minus of minus plus. Minus 12, minus 12, minus 24. So these about the cofactors of elements of A. And we can write down adjoint A is nothing but the cofactor matrix. The transpose cofactor matrix A, transpose of it. And let me consider the system here. Ax is equals to B. As inverse is existing, if I multiply A inverse both sides, A inverse multiply by B. And this simplifies it as X is equals to A inverse B, which is nothing but adjoint A by det A multiplied by B matrix. So X can be written it as 1 by determinant of A. We had the determinant is equals to 1200. Multiply by adjoint of the matrix, which is the transpose of this matrix. Row wise, if I take up 75, 110, 72, 75, 110, 72. Second row 150, 100, 0, 150 minus 100 and 0. And the third row 75, 30 minus 24. 75, 30 minus 24. Yes, of course, these are the values and multiply by the B matrix. So what is the B matrix here? This one, column matrix 4, 1, 2. So it is a 4, 1, 2. And when you multiply this, you'll be getting 1 by 1200 times of the value 75 fours. Yes, 300 and plus 150, 450 plus 150. Yes, 300 plus 300, 600. And 110 multiplied by 4, 440 minus 100, 340 plus 60, 400 plus 60, 400. So 500 minus this one, 400 you get it. And the next one 72 4 times 288 plus 0 minus 48. Subtracting, I hope we'll be getting 240. And therefore, I'll write here 1 by 1200. X is equals to 1 by 1200 times of 300 plus 300 is 600. Next, 400 plus 60, 440 plus 60, 500 minus 100 is a 400. And 288 minus 48, 240. It is 240. So dividing by 1200, you will be getting it as 600 by 1200, 1 by 2. 400 by this one is 1 by 3. And this is 1 by 5. And of course, X matrix is nothing but actually 1 by X, 1 by Y, 1 by Z. So clearly when you compare X is equals to 2, Y is equals to 3 and Z is equals to 5 is a solution for the system. 2, 3, 5. So 2, 3, 5 is the solution for this system. Hope you understood. This is about the solution for the example 4. Let's proceed to the example 5. Next one. The description is given to you. Sum of the three numbers is equals to 6. And if we multiply the third number by 3 and the second number and add it to the second number, we get 11. By adding the first and third numbers, we get the double of the second number. Represent it algebraically and find the numbers using matrix method. So let us proceed. I would assume let the numbers be. Let the numbers be x comma y comma z. Now I shall proceed by rewriting the equations here itself so that it's convenient to write down the values. Sum of the three numbers is 6, means x plus y plus z is equals to 6. Sum of the three numbers. And if you multiply third number by 3, that's nothing but 3z. And the second number to add, and add the second number to it plus y to get 11. To get 11. By adding the first and third numbers, x plus z, x plus z, we get double of the second number. That means 2y. So we can rewrite the system x plus y plus z is equals to 6. I'll write here x plus y plus z is equals to 6. Second one, y plus 3z equals 11. Y plus 3z is equals to 11. And x minus 2y plus z equals to 0. X minus 2y plus z is equals to 0. And of course, this system can be written it as, yes, of course, 1, 1, 1, 0, 1, 3, 1 minus 2, 1, multiply by x, y, z, and that is equals to 6, 11, 0, and this is nothing but AX is equals to B form, where A matrix is equals to this one. We have to solve now. So let me calculate the determinant of A, which is nothing but 1, 1, 1, 0, 1, 3, 1 minus 2, 1. The determinant is equals to 1 multiplied by 1 plus 6 minus 1 multiplied by, it's 0 minus 3 plus 1 multiplied by 0 minus 1. So 7 plus 3, 10 minus 1, 9. So that is equal to 9, which is not equal to 0. Determinant of A not equal to 0, which implies A inverse exists. That means system has the solution. It is consistent. System is consistent. It has unique solution. And therefore, let me calculate the cofactors of elements of A. Cofactors of elements of A in the same model. Elements of A is equals to. We calculate the cofactors like this. First row, first column element, it is 1, 3 minus 2, 1. And second one, it's 0, 3, 1, 1 minus sign. And for the third one, 0, 1, 1 minus 2. And for 0, 1, 1 minus 2, 1 with the minus sign. And for 1, it is 1, 1, 1, 1. And for 3, 1, 1, 1 minus 2. And for 1, it will be 1, 1, 1, 3. And for minus 2, 1, 1, 0, 3 with the minus sign. And for 1, 1, 1, 0, 1. Let me evaluate these values. I think 1 plus 6, it is 7. And 0 minus plus 3, and 0 minus 1. 1 plus 2, 3 with the minus sign. 1 minus 1, 0. Minus 1 minus 2. Of course, we have to take minus sign here. Minus of minus 3 plus 3. It's 3 minus 1, 2. 3 minus 0 minus 3, get it? And it is 1. So 7, 3 minus 1. 7, 3 minus 1. Minus 3, 0, 3. 2 minus 3, 1. And of course, adjoint of the matrix is nothing but the cofactor. And adjoint of A. Adjoint A is nothing but cofactor matrix. So the transpose of the cofactors matrix is nothing but adjoint A. Let me take up the system AX is equals to B multiplying A inverse both sides. AX is equals to A inverse B. A inverse into A is identity matrix multiplied by X. You will be getting it as A inverse B. And thereby you could say that it is adjoint A by det A multiplied by B matrix. So therefore X is equals to, written it as 1 by det A. The determinant of A is equals to 9. So 1 by 9 multiplied by adjoint of the matrix. We calculate the adjoint matrix is the transpose of this matrix. So 7, 3 minus 1, row wise, we write down column wise. 7, 3 minus 1. 7, 3 minus 1. Minus 3, 0, 3. Minus 3, 0, 3. 2 minus 3, 1. 2 minus 3, 1. This is about adjoint A multiplied by the B matrix. The B matrix is equals to 6, 11, 0. So 6, 11, 0. And the product is given by X matrix is equals to. So X is equals to 1 by 9 times the product. Let's see. 42. First row, first column. 42 minus 33 plus 0. Next one. 18 plus 0 plus 0. And next minus 6 plus 33 plus 0. And that is equals to 1 by 9 times of 42 minus 33. That is 9, 18 and 27. Dividing by 9, that is equals to 1, 2, 3. And that is X matrix is X, Y, Z. And thereby solution for this system is X is equals to 1, Y is equals to 2, Z is equals to 3. This is how we find the solution for the system. Okay, this is about the solution for the system of these equations. Hope you understood the logic of the system here. The system can be put up into the matrix notation like Ax is equals to B. Find out a determinant of A. Check whether det A is not equal to 0 or not. And decide about the existence of A inverse. After calculating the cofactors, then calculate the adjoint of A is the transpose of that matrix. You can write down, no issue. Then X is equals to A inverse B is nothing but adjoint A by det A multiplied by B. And writing that X is equals to this one and simplifying, you'll be getting the X, Y, Z values. So hope you understood the linear system of linear equations and consistency and how to find the solution for the system by using matrix inversion method. This is about this lesson using system of equations. Almost all the problems have been done. And the next lesson we continue with a few all revision different kinds of the problems as NCERT problems we'll take up and we'll discuss it. And get back to the homework solutions. Submit the homework by working out the solutions from the manual. And in case any doubts, get back to the doubt clarification number, post it and then get clarified and then submit the homework. Thank you.